All right, this is section 6.4 notes. This is comparing linear and nonlinear functions. Okay, so the graph of a linear function shows a constant rate of change, and a nonlinear function does not have a constant rate of change, so its graph is not a line. Okay, so an example, oops, dropped my pen. An example of a linear function would be a straight line. Okay, so this would be a linear function, and a nonlinear function would look something like that. Okay, it's not a line. Example 1, once you identify functions from a table, so it wants to ask, does the table represent a linear or nonlinear function? Okay, and remember when we have a linear function, it has to have a constant rate of change, which means your y's have to change by the same amount. So this is -8, -8, and -8. And your x's have to change by the same amount. So this would be +3, +3, +3. Since these are both constant rates of change, you can find a slope from this table. So this would be a linear function. The second one, from 2 to 11, I'm adding 9. From 11 to 33, I'm adding 22. And from 33 to 88, I'm adding 55. And up here, I'm adding 2 every time. So the x's are constant, but since the y's are not constant, this does not have a constant rate of change. So this is a non-linear function. All right, example 2 wants you to identify functions from a graph. So identifying whether it's linear or non-linear. Okay, so this first graph on the left, this is obviously a curved line. So this is a non-linear function. And the second graph is a straight line. So this would be a linear function. Okay, notice some of you are going to ask me, this doesn't have a slope. Well, that's okay. It does have a slope. The slope is actually 0. Okay, so the only straight line that's not a function would be a vertical line. This is horizontal, so we're good. So on these on your own, I want you to pause this. I want you to try them on your own and press play when you are finished and check your answers. So the change in x is I'm adding 7 each time. And on the y's, I'm subtracting 5 each time. So this is a constant rate of change. They are changing in the same pattern. So this is a linear function. Question 2, I'm adding 2 on all the x's. And on the y's, I'm subtracting 4, and subtracting 4. So number 2 is also a linear function. As x increases by 2, y decreases by 4. And part 3 is a nonlinear function because this is not a straight line. Now you're going to say, well, both of these lines are straight. Together, they do not make a complete straight line. You can't have this point. So example 3, it says, which equation represents a nonlinear function? Okay, for an equation to be a function, it has to be able to be written into slope-intercept form. So for an equation to be a function, it has to be y equals mx plus b. Okay, so these 4 equations, some of them need to be rewritten in the form of y equals mx plus b. A is fine. If y is 4.7, it would just be, you'll go up to 4.7, and this would be that line, so that's okay. B, y equals pi times x, okay? So pi is your slope, which is 3.14, going through the origin, so it'd be something like that. And part D, I can distribute this 4 and make it 4x minus 4. There's your slope, there's your y-intercept. Something like that. Once again, I'm just sketching these graphs. Part C is the only one that I cannot change into y equals mx plus b form. This, if I even changed it a little bit, it would be y equals 4 divided by x. Okay, and I can't, there's no way I can change that into looking like slope-intercept form. So the answer to this is C. And last one, you're welcome because I helped you out a lot on this problem by not making you graph. It says account A earns simple interest, account B earns compound interest. Okay, so the table shows the balance for 5 years. Graph the data and compare the graphs. Okay, so I graphed it for you over here. Here's your table. So this means after 0 years, account A has $100 and account B has $100. Okay, after 1 year, they've both earned both earned $10 more. Okay, after 2 years, account A earns $10 and account B earns $11. And then you can see each time account A is earning $10, but account B is earning a little bit different. So this would be, if I get out my calculator, 133.10 minus 121. What did I do? Sorry, I just went ahead and did those calculations so you wouldn't have to watch me use the calculator. But as you can see, account A increases by $10 each time, and account B is increasing by more each time. So I want you to somehow compare these results. I want you to talk about what happens to their balances. They're both obviously increasing. They're both positive. Account A, talk a little bit how this is a constant rate. Okay, so what type of function is account A? I also want you to talk about what type of function would account B be. Would it be linear or nonlinear? So take a minute and write a couple sentences on what you think this graph represents. And lastly, the on your owns 4, 5, and 6. All you have to say is, does the equation represent a linear or a nonlinear function? Remember, for it to be linear, it has to be able to be written in the form of y equals mx plus b. So this is my m, this is my b, number 4, yes, is a function. Okay. Number 5, this is the same thing as saying 4x divided by 3, and there's no way I can write it in the form of mx plus b. So this is a, oops, this should be linear function, sorry. This is a non-linear function for number 2. And number 6 is 1 minus x squared. Pay attention to that x squared. That's the same thing as saying negative x squared plus 1. Although that looks very, very similar to slope-intercept form, you cannot have the square in slope-intercept form. So this is a nonlinear function. And I think that's it. See you tomorrow.